All right, the next shape we'll be talking about is the surface area of a cone. So a cone is a shape that has a base of a circle, like that, a point at the top, or a vertex, and lines that come down that meet it. And it's kind of just like your average ice cream cone, hence the name cone. So let's say that in our cone, we have the base circle having a radius of length r, and the height of the cone, right here, still 9 degrees, of height h. So just like before for surface area, we're going to be analyzing the shape and finding the surface area by summing up or adding up the different faces of this shape. So first, let's talk about the most obvious shape, which is the circle on the bottom. This area right here. And this circle has a radius of r, and using our formula, we know that this surface area is equal to pi r squared, where pi is 3.14159 or 3.14, or anything you might remember. Apart from this shape, we also have the more complicated shape of this entire cone, which is the side of this cone right here. So ignore the bottom and just think about the side. If you take this side and lay it out, you'll find that you have a shape that looks like this. So with this shape, you basically curl it around the center circle right there. And if you unravel it, you'll have this shape. And we call this shape a fan shape. Let me draw that a bit better since it's a little crooked. All right. So something you'll notice about this fan shape is that it kind of looks like a section or a random arc of a bigger circle. And if you thought that or noticed that, then you're right, since this fan comes from a various arc of a larger circle. So how do we find the area of this fan? If we knew this radius right here, it would be and the center angle right here. That'd be very simple since we would already know exactly how to do it. But since we don't know that necessarily, especially the radius, we need to think about it more. I'm going to erase this for now so that it doesn't take up that much space, so something we'll notice once again, so with the Pythagorean Theorem again, is that RH and this length right here, or conveniently, the radius of the big circle, or the fan, which we'll label as big R, are in a Pythagorean relationship again, since they share a common right angle. That's a common theme you'll find in a lot of geometry problems like this. For any length you don't know can be found by using a Pythagorean theorem with any other lengths or sides that you may already know the magnitude to. So let's move this triangle down again. We have this triangle right here. This R, or the radius of the circle, is related to h and r with r squared is equal to h squared plus r squared. R is equal to square root of h squared plus r squared. My writing's kind of bad, I'm sorry. And with this, you could determine what r is. And now that we know r, the only thing we need to do is know this angle right here. Let's label this angle theta, or that shape. So usually in grade 9 math, they'll tell you what this angle is, but once you get into high school, you'll learn other ways to determine the surface area of this fan shape. For now, I'm just going to say that in the PAT, there's a very, very, very slim chance that they won't give you this angle. But if they do, they'll definitely give you the R, they'll definitely give you all the different, or the area of this entire shape already to help you determine any other variables you don't need to know. But all right, let's say that this fan has a shape, central angle of side of magnitude theta. And with all of these, we can determine the area. So the surface area of this cone would equal pi r squared for the circle on the bottom, plus the area of this big circle that connects all this would be pi big R squared. But since it's only a section of it, we multiply by a fraction, and this fraction is usually just theta over 360 degrees. Notice that these angles are both in degree measurement. And this theta over 360 degrees just indicates how much of the overall circle that this fan is taking up. Pretty simple, it's just a fraction of another area. And if we want to simplify this even further, we have pi r squared plus pi r squared is equal to h squared plus r squared, all squared again for the r squared, times theta degrees over 360 degrees. Even further, square root squared, we can cancel that out, plus theta pi squared plus r squared, h squared, sorry, plus r squared, times theta over 360 degrees. And with that, we have the surface area of the cones. Just keep in mind for future problems that when you're breaking down surface areas, you always want to look at the individual faces first. So I suggest drawing them out just like this, or like I did with the rectangular prism. And with that, you'll be able to look at these shapes kind of straight on more. And with that, find new knowledge that may prove useful to you.